All right, Algebra 2 students, this is the review video for Unit 1. Spent a lot of time on sequences. What we're going to do, at least what I'm going to do to start with though, is I'm going to go back and review functions a second. I think we had a quiz over functions eventually, and it was more just getting used to the notation. When you're given an equation that involves function notation, I suggested, making a box, knowing the name was f, knowing the rule that it followed, and knowing that whatever was in this spot, that doesn't mean multiply, that's the input, that's the domain, okay? And then we would do stuff like this. I would say, what's f of 3? And what that meant was simply, I'm going to take 3, I'm going to put it in the machine. 2 times 3 is 6, 6 plus 5 is 11, out would come 11. And then I'd say, well, what's f of 7? Same thing, I just plug 7 into the machine. As the input is the domain, 2 times 7 is 14, 14 plus 5 is 19. And the stuff that came out we called range or the Y's values, okay? Now you might say, well, yeah, that's functions, but what's that have to do with sequences, okay? Well, sequences are pretty similar. Sequences follow a rule. We put the term number in, and out comes whatever the term is. The biggest difference between a function and a sequence is this, though. If I'm dealing with just functions, I could plug in f of a half. It was all right to plug in whatever I wanted. I mean, if I wanted to plug in 2.7569, I could plug 2.7569 in. I would need a calculator probably, but I could do that. Just like if I plug in a half, 2 times a half is 1, 1 plus 5 is 6. The difference with the sequence, though, is you can't plug in a half or 2.7569. And the reason why is this is the term number. So this, like if this was a sequence, I'd be finding the third term. I'd be finding the seventh term. It doesn't make any sense to find the 2.7569 term. Okay, so anyway, just a little review on the difference between a function where you can plug anything you want in and a sequence where you have to plug in the term number, the 0th term, the first term, the second term, the third term, etc. All right, so here we go, on to the actual review. See if we can make this work correctly. First of all, notation. Here are the first 5 terms of the sequence, okay? The first term is 2. Now, I know they have it written out. I really like to kind of do it just like this. There's the first term. It's 2. The second term is 6. Okay? The third term is 10. The fourth term, etc., is 14. So whenever I can actually list them out, I think it helps. What formula defines this sequence? Now, let's look at this sequence. What's happening? Well, it sure looks like they're just adding 4 every time, okay? And that right away tells us some things, okay? If you add the same number over and over again, it's called an arithmetic sequence. That will come up later, not necessarily right now, but if you add the same number every time, it's called an arithmetic sequence. If you would multiply by the same amount every time, it'd be called geometric. So this is an arithmetic, okay? Next thing. There's 2 ways we define sequences, okay? One is called a recursive formula. And all a recursive formula means is you're using the previous term to get the next one. You're doing something to the previous term to get the next one. Simple is what a recursive formula means. And that's what, oh, maybe not. Maybe they have an explicit one here on this one. But anyway, that's what recursive formula means. You're using the previous term to get the next one, okay? There's also what are called explicit formulas, and we'll go over this a little later, okay? And what an explicit formula does, or what's nice about an explicit formula is you can jump to any term you want. So for example, with recursive, hey, I know the first, second, third, fourth, fifth, sixth, seventh, I can go in order, okay, and it works. But if I said, what's the 135th? I'd rather have the explicit formula, okay? Why? Because the explicit formula allows you to jump to whichever one you need, okay? Now, as I look at this, okay, This is like I said, this is an arithmetic one. How do I know? We're adding 4. Let's look at our choices. Okay? The common difference here is 4. So of this multiple choice, okay, I can already rule out one of the answers. And here's how I know. We know the first term's 2. Okay? D says the first term's 6. So I can get rid of that one already. It's not going to be that answer. Okay? Now let's see. What did I do? Well, once I knew the term, if I needed to find term, I took the previous one and added 4. I took the previous one and added 4. When I look at this, I think the only one that adds 4 every time is B. Now, let's talk through this. To find the current term, remember we say this is the current term. You take the previous term. Okay, this is the previous term. That's notation for current, previous, one before, and add 4. And so your answer to that would be B. A lot of talking for B. Number 2, same thing. Write down the first 5 terms of the sequence. A little different. I tell you the first term is 3, or they tell you the first term is 3. And then I have to decide, how do I get the next one? And once again, how do I interpret this mathematical language? This means current term. This means previous term. Well, take the previous times 2, it looks like. So if I take the previous term times 2, 6, 12, 24, 48, 96. 1, 2, 3. I guess I did 6 terms there. Okay, up above I mentioned if you have repeated addition, it's arithmetic. This was not repeated addition, this was repeated multiplication. So this would be considered a geometric sequence. Write the explicit formula for this sequence. Okay, so they gave us the recursive one up here. The explicit formula for a geometric sequence. There's more than one way to do it. This is the way I prefer. To find the term, start with the 0th term times, okay, whatever your rate is. You know, what are you multiplying by? Raised to the n. I'll move that over so you can see it. Okay. The explicit formula for geometric is you start with the 0th term, okay, and you times it by whatever your rate is, raised to the n. Remember, n stands for the term number. So when I ask, well, I guess that's I got to finish C before I go on. So for C, the explicit formula for this one would be, do I know the 0th term? They gave me what? They gave me the first term. Could I go back and find the 0th term? Yeah. If I go back and find the 0th term, see, I'm doubling it, I'm doubling it, I'm doubling it, I'm doubling it, I'm doubling it. So if I go back, I'm cutting it in half, cutting it in half, cutting. The 0th term would be what? 3 halves, okay? So the 0th term is 1.5 or 3 halves times. Now what did we say we were doing every time? We were doubling it. That's our rate, raised to the nth power. That is an explicit formula, okay? That is one form of the explicit formula for the geometric sequence. I kind of prefer that, okay? Like I said, I kind of like to go 0th term, rate to the end. However, the book, and some of you, there is a second way to do this. And if this is going to confuse you, just plug your ears and don't watch it. You can write the rule starting with the first term, okay? So, like I said, I prefer starting with the 0th times the rate raised to the n. But if you start it with the first term, so I'll write first term, it would look like this. Start with the first term, not the 0th. It's still times the rate, but then you have to go to the n minus 1 power. Okay? And like I said, if that confuses you, just blot it from your mind. Don't write it down. Don't think about it. Just start with, hey, if I want to find the current term, 0th term times rate times n. Okay? Now, I ask you to find the 27th term, and I'm going to use this. So I have, if I'm finding, I'll do it right underneath here. If I'm finding f of 27, the 27th term, I am taking 3 halves. Oh, this is going to be ginormous. I don't know. Luke, hand me your calculator. 3 halves times 2 raised to the 27th power. And like I said, this is going to be a huge number. When I made that up, I probably made it too big. Okay, 27 raised, or excuse me, 2 raised to the 27th power, grande, times 1.5, or 3 halves, and it gives me, maybe, I'll write that up there. So if I put decimals, or 201,326,592, 201,326, 201,326,592. 201,326,592. So that would be your 27th term of that geometric sequence. Okay. Still debating. I might put the explicit formulas up for you. I don't know yet. Okay. I'll let you know the day before. Okay, whether you have to memorize it or not. Okay, second page. Here we go. It looks like we have, I don't know, a dog, a horse, a giraffe, I don't know. We have these steps. Here's a growing patterns of squares. Now, I continue. I like the numbers, the tables. So the first thing I'm going to do is I'm just going to count this. 1, 2, 3, 4, 5, 6, 7, 8. So my first term is 8. Maybe I should just put it there. My first term is 8. There's 8 of them. 2, 4, 5, 6, 7, 8. My second term, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 for my second term. Now, I'm guessing that it's arithmetic and the next one's going to be 14, but I'll check. 4, 8, 9, 10, 11, 12, 13, 14. Okay? Third term is 14. So this appears to be geometric or arithmetic. I would say arithmetic. Why? We were adding the same amount every time. Write a recursive formula for this. Well, to find the next one, or excuse me, to find the current one, take the previous one. To find the current one, take the previous one. And what do we do every time? Looks like we added 3. You're not going to get full credit if that's all you write, though. Okay? If you want full credit for a recursive formula, you have to tell me where you started. I agree. We add 3 to the previous one, but you also have to tell me, hey, the first term, the first step was 8. All of that needs to be included to get full credit for B. Okay. C, write the explicit formula for this sequence. Now, if you remember just a second ago, we wrote the explicit formula for a geometric series. I should write that above it, geometric. Okay, we started with the 0th term times the rate raised to n. But this isn't a geometric. This is a arithmetic one. Okay. Once again, there's kind of 2 ways to do it. The one I prefer for the explicit formula, I wonder if I can come over here and give myself a little room. The explicit formula for arithmetic one, I like to start not with the 0th term, but with the first term. Okay? Okay, start with the first term plus, now what was the common difference here? Well, it was 3. So then I have the first term, then I have the common difference, that's what the CD is going to stand for, times n minus 1. Okay, first term plus the common difference times n minus 1. So for our problem, the first term was 8 plus the common difference was we were adding 3 every time, and it's to the n minus 1. Remember, n stands for the term, n minus 1. There. That would be the explicit formula. Now, by the way, if you want to check to see if you did it right, okay, you know what the third term is, don't you? It's 14. Just check to see if you did it right. Okay, if I'm trying to find the third term, is it 14? Let's see, I'm looking for the third term, so I put 3 there. 3 minus 1 is 2. 3 times 2 is 6. 8 plus 6 is 14. Oh, yeah, it was. That was right. I do have it incorrect. Okay? Write the explicit formula. We did it. How many blocks would it take to make step 10? So really, now we're asking, what is the 10th term? 10th step. So it'd be 8 plus 3 times, now even though I'm looking for the 10th one, I use 10 minus 1, it's going to be 9. So 9 times 3 is 27. 27 plus 8 is 35. The answer to D would be 35 blocks. 35. Okay. So this was the explicit formula for arithmetic. There's also one where you could have started with the 0th term and used n. Okay. I don't think I'll write it up there. I don't want to confuse it. That's where we're at. All right, final question on this one. Which step are you on if you're using 74 blocks? Well, I'm going to go back to my formula, which is right here. And I'm going to write 8 plus 3 times n minus 1. And I want it to equal 74. I want to know what step to get 74 blocks. So now you got to do a little algebra. I'm going to subtract the 8 over. Okay, when I subtract the 8 over, I get 3 times n minus 1 equals, let's see, 66. Okay, then I'll probably distribute the 3, although some of you would divide by 3 here. It doesn't really matter. So if I distribute the 3, I get 3n minus 3 equals 66. I add the 3, so I get 3n equals 69. And then I divide by 3, and it looks like I'd be on step number 23. Step number 23 would use 74 blocks. All right. I haven't decided. Number 4 is probably in my opinion, maybe the hardest one on here. And here's why I say that. I don't think I've given you one, or the book's given you one, where they didn't give you this sequence in order. Here they give us the first term, the third term, and the 7th term. Okay? And I don't know if that'll throw you off or not, but I'm just going to say, okay, the first term was 3. I don't know the second term. I do know the third term, though. What is the third term? It's 8. I don't know the 4th term. I don't know the 5th term. I don't know the 6th term. But I know the 7th term is 18. Okay. So now the question is, are we multiplying? Are we adding? You know, what are we doing here? Okay. Well, let's see. If I went up from 3 to 8, okay. And to be honest with you, it might also be neither. Remember, there's arithmetic, there's geometric, and sometimes it's neither. And you just have to figure out the pattern. Okay? So I think, let's see, I had 2 jumps and I got up to 8. I went up 5 and 2, okay. What would I be going up by? Well, 3, 8, that would be 5. I'm going up 2.5. So let's see, 3, 5.5, 8, 10.5, 13, 15.5. Ooh, it does look like, I think I am adding 2.5 every time. Am I not? Did I do that right in my head? I got to think about this. 3. And then if I'm adding 2.5, this would be what? 5.5. 5.5 plus 2, that'd be 8. And then this would be 10.5. And then at 12.5, this would be 13. This would be 15.5. So, oh, I think I found it. Now, I won't say the name. I think there's other ways you can define this. And someone yesterday, I think, showed me another way. So don't think, like, there might be another way to represent this. Okay? But to me, the first term was 3, the third term was 8, and the fourth, fifth, sixth, 7 was 18. I think this is going to work. Okay, write a recursive definition. Okay. The recursive definition could look like this. Okay. The current term is found by taking the previous term and adding 2.5 to it. Now remember, that doesn't get you full credit. You have to also tell me what? The first term was 3. Now I'm trying to remember what I was shown yesterday. I think it was add the previous term. I don't remember for sure, but this way works as well. Okay? All right. Turn the page. Number 5. A piece of paper has an area of 81 square centimeters. A strip is cut off that is 1/3 of the original. From that strip, another strip is cut off that is 1/3 of it. So it looks like they're taking in, and they're taking a third every time. Here's a graph and a table. So here's a graph and a table representing this. No cuts, 81. Now, if you take something times a third, I think you know that means the same as you're dividing by 3. And you can see that's what's happening. Dividing by 3, dividing by 3, dividing by 3. Or you could say multiplying by a third, multiplying by a third, multiplying by a third. And then you see the same thing over here. 0 cuts was up at 81. After 1, you were down at 27. Okay, after 2, you were down to 9, etc. First question, is it geometric or arithmetic? Explain how you know. This can be geometric. How do I know? We multiplied by 1/3 every time. That's the definition of a geometric sequence. Multiply by 1/3 every time. Write an equation to define it recursively. Well, first thing I'm going to say is the 0th term was 81. And to be honest with you, I don't care if you use the 0th or the first, but you have to give us a term. And then you just say, to get the current term, you take the previous term, you times it by a third. That's what we did. To get the current term, you take the previous term times a third. Okay. Oh, I used F there, but I noticed in this problem they're using K, probably for cuts, I suppose. I don't know. For the nth term, what are some values of n that make sense to use? What are some values of n that don't make sense to you? Explain how you know. Well, remember, what does n stand for? N stands for the number of cuts. Okay? So some things that would be this is you aren't going to have any negative number of cuts. Okay? You're not going to have any negative number. Okay? You're probably not going to have 10,000 of them because it would just be too small. So maybe you could say n could be smaller whole numbers. That kind of makes sense to me. Have 1 cut, 2 cuts, 3 cuts, etc. In other words, that's adjusting your domain, your input, to something that makes sense. All right, got to keep moving here. Number 6. They give us some information. They tell us the first term is 2. They tell us the second term is 6. They do that for both of them. The first term is 2. The second term is 6. But here's what I'm checking, or they're checking. Do you know what this word means? It means adding. We added 4. We add 4. We add 4. We add 4. Okay? He says, explain your reasoning. You say, arithmetic means add. Okay? Geometric. Hold it. H is there. Write a definition for the nth term. Explain your show. Okay. So I guess I'm not quite done. I've got to write the definition for the nth term. They want the explicit formula. So we said that a little bit ago. When I do arithmetic explicit formula, I like to use the first term, which would be 2, okay, plus the common difference, which was 4. Remember, the common difference here is 4. And I use the n minus 1. And if you're never sure if you did it right, like I said, this check. Like, watch. The first, second, third, fourth. The fifth term is 18. Let's see if that works. Is the fifth term 18? Let's see. Term 5. 5 minus 1 is 4. 4 times 4 is 16. 16 plus 2 is 18. It is. So that's the explicit arithmetic sequence. Now this one's geometric. Times 3. Times 3. Times 3, I think. Okay? Okay. Explain your reasoning. Well, it's multiplying, therefore it's geometric. And with the geometric, if you remember, I like to start with the 0th term. Do I have the 0th term here? They didn't give it to me. Let's see. Divide by 3, divide by 3, divide by 3, divide by 3. I could start with it. 2/3 times the rate, which in this case we're tripling it every time, raise it to the n power. If you started, maybe I'll show here, if you started with the first term, you could have used the 2. It still would have been 3. It just would have been the n minus 1 power. So I don't really care. I kind of like to use the 0th term. But if you want to use the first term, it doesn't really matter to me. All right. Final question. Hallelujah. Here are 2 sequences. Okay. Sequence A, they gave us a table form. I think I'll look at it a little more closely before I even look at sequence B. Let's see. If I double 1/4, I get 1/2. If I double 1/2, I get 1. If I double 1, I get 2. If I double 2, this appears to be times 2 every time. That tells me it's geometric. Let's see here. Let's see what happened here. Term number, 0th term was 2. The first term was 12. The second term was 22. It looks to me like they're adding 10 every time. And by the way, arithmetic sequences look like lines. Okay, so this is going to be arithmetic. Looks like we're adding 10 every time. Now that we've kind of studied each thing, we can go ahead and answer the questions. Sequence A, describe a way to produce each new term from the previous one. Okay? All you have to say is take, if you want the current term, take the previous term and times it by 2. In sequence A, that's all we did every time. We're times it by 2. Current term, previous term times 2. Sequence B, okay, same thing. Well, take the current term, or to get the current term, take the previous term, and actually I kind of went back on what I was just screaming at you guys about, and add 10. Now, I'm going to go back up here. If I handed that in, I probably missed a point, because I always said if you're doing a recursive one, you got to tell me like one of the terms. So if you said, hey, the 0th term was 1/4, that's good. Tell me where I'm starting. Okay? On this one for sequence B, if you say, hey, the 0th term is 2, that's good. Tell me where you're starting. With recursive ones, tell me where you're starting. All right? Last 2 parts, C and D. Now they want the explicit ones. When they ask for the nth term, that means that could be any term. The 100th, the 200th, the 75th. You got to be able to jump. Okay? So we said, remember, sequence A is the geometric one, where we were times in by 2 up there. So I'll say, if I want to find any term I want, remember with geometric, I like to start with the 0th term. The 0th term was 1/4 times, what was the rate? We were multiplying by 2 every time. You raise it to the n power. Sorry. So for the explicit geometric one, start with the 0th term, times it by the rate, raise it to the n power. For the arithmetic one, Okay, I like to start with the first term, which was 12, plus the common difference, we were adding 10 every time, and then the n minus 1 power. Not power, this time's n minus 1. All right. And that, my fine young friends, is your first review video. I hope it helps you.